Hey guys, I'm Exodia, and today we're doing part 3 in our placement system series. And today we're going to be making it to where you can place your object on specific ground types. In this case, I have this metal plate here, and we can place it. We're going to make it to where we can only place it on this metal plate rather than on anywhere in the base plate that we want. And to do so, we're going to use raycasting. Now, some new things that you're going to need to make is, of course, your ground in your game. You'll probably already have this, other than a text label inside of our placement GUI. This is just going to be called a message. You can customize it however you want, but we're just going to use this as something to inform the player of when they're trying to place something on the incorrect ground type, just so that they know, okay, I have to place this here instead of on the base plate. So to start, we'll hop into the placement client script, and then we're going to make a new function, and this is going to be called local function fire ray. And then we'll pass the clone chair as parameters for it. Now, what we're going to do here is we're going to be casting a ray from the base of our object. So we have the base part here, which we have we're using the track to placement. We're going to cast a ray from this part before placing it. Either we're going to detect to see if that ray is hitting our object, so that way we know that, okay, it's good to place because we're meeting all the requirements, it's on the right ground type. So yeah, to raycast, what you'll need to do is define a few things first. We'll need to define an origin for our ray, which will be the part that the ray is coming from. So our local origin point equals clone chair dot base. And then we'll also need a ray direction. So ray direction, and this will be the direction that the ray travels in. And we'll make this vector3 dot new, and we'll do clone chair dot base dot position dot x, clone chair dot base dot position dot y minus 25, and then clone chair dot position, or clone chair dot base dot position, my bad, clone chair dot base dot position dot z. And so the reason that we're writing like this is that we're going to cast the ray from the base's position, or from the primary part's position on the x and z axis. Either we're going to cast it in the direction of 25 studs below the base. So that way the ray will always get casted directly under your object when placing it, so we can detect to see if it's on the appropriate ground type. Some things that we'll also need to define for our raycast is raycast parameters. And there are two main things that we'll need to define. There are 4 total parameters for your raycast params, but there are 2 main important ones that we'll need to define. And that'll be filter descendants instances as well as the filter type. So first we got to do local raycast params equals raycast params dot new, and then raycast params dot filter descendants instances, and we'll set that equal to a table, and this table will be the parent of our origin point. So origin point dot parent. This will be a filter just so the ray isn't casting through our model and accidentally hitting those parts instead of the ones that we want it to hit. And then we'll also need to define a filter type. So raycast params dot filter type equals enum dot raycast filter type dot blacklist. And what this will do is it's defining that, okay, in our filter descendants instances, this is what we're choosing to filter, and the filter type is how we are filtering it. So the blacklist will make it to where we're ignoring it in our raycast. And then local raycast result, which is basically just going to be the ray itself. And we'll set that equal to workspace colon raycast. And then there are 3 main parameters that we need for this. If you autofill it, you can see we need the vector3 origin, vector3 direction, as well as our raycast params we just defined. So for that, we'll do our origin point dot position, our ray direction, as well as our raycast params. And now what we'll do is we could check this raycast result because it'll return a part that it hits. So you can check if raycast result, which means that if the raycast does actually end up hitting something, then this if statement will trigger. So in this case, we want to check local hit part equals raycast result dot instance, which is the instance that the raycast hits. And so we can check if hit part dot name equals, in my case, my part's called ground. You can call it whatever you want. Just make sure that you're defining that name here properly. So if hit part dot name equals ground, then what we'll do is instead of firing the event whenever we're clicking, we can comment this out for now, and instead fire the event if the condition is met. And instead what we'll do is when we left click on our mouse, we will call the fire ray function and pass our clone chair. And let's test this in Studio just to see if it works. So we go to place our chair. As you can see, nothing happens. We just place it, and then it just nothing ends up happening because we're not firing the event because it's not placed on our ground. However, if we go over this ground part that we place, looks like nothing happened, which is okay. Stuff like that will tend to happen. So what we'll do is, if we get a raycast result, we're actually going to print the hit part. So we'll print hit part dot name. Now let's see what happens when we do that. Okay, so after looking at it for a few minutes off camera, I realized what's going on here and what's causing our raycast to not hit anything. Because what was happening is it was returning a nil value. It turns out that our base is actually too low of a position. So what I'm going to do, and what I'd like you guys to do as well with your object, is to make a hitbox for it. And what I mean by that is just like take any part, and here I'm just going to take the seat part. In fact, I'll just take the base itself, and I'm going to call this hitbox. And I'm just going to position this in about the middle of my object, and then I'm going to size it to where it envelops the whole thing. As well as I'm going to move the base up. In fact, not. I'm going to actually shrink the base and make sure it's as close to the chair as possible so that it's not like under the chair or anything. And then what we'll do is, instead of raycasting from the base, we'll raycast from this hitbox. And what we could also do is, in a future part, use that same hitbox to detect if two hitboxes are inside of each other, and that way we can make sure that we're not placing chairs or objects inside of each other. So what we'll do is we'll define this as clone chair dot hitbox instead, and then we'll raycast from there. And let's see. So yeah, as you can see, it's printing it because I put a print in just to do some minor debugging. And now, as you can see, we can only place the chair on top of our ground. Now, there is a little bit of a problem with this though, however, because the raycast is very thin. So you could put the... Oh wait. Never mind. Okay, so the beauty of this is that the raycast will only be able, because we're using the raycast, before I thought that it would only be directly in the center. No, it's the whole part, it looks like. So it looks like we have to have the part the object over this ground to be able to place on there, which is actually perfect. I did not expect this is. I don't know why, but I didn't even think that would happen. But that works better because we don't have to do any extra stuff in our script to make sure that works properly. So yeah, you can only place chairs in the constraints. In fact, you can't even place them within each other. So we don't even need to use the hitbox for any extra calculations there. Because I would use like region 3s. But yeah, you have to place the chairs separate from each other. So what we're going to do now is we are actually going to code the GUI code the message GUI just so we could tell the player, hey, you didn't actually hit the proper ground type. Try again. So what we'll do is we'll make a local message. And that'll be for our message text label equals script.parent : find first. In fact, we'll do script.parent : find first child message. And so if hitPart.name equals ground, then else message.text. So message.text, we'll set it equal to your object is not actually we'll just say can't place the object. Can't place the object here. And then what we'll do is we'll just set the text color to red. Actually set this text stroke to white. And we'll set this to, on the Y position, we'll set it to -0.1. And so what we'll do is message : tween position udim2.new 0.50 0.10 and then out quint 1 true. In fact, we'll do linear here for our easing style. Okay, that's a little high, so we'll just set it to 0.05. We'll actually set the text before tweening, just so there isn't any issues. And then we'll wait 1, and then message : tween position. In fact, we don't even have to send the text. We'll just set that text manually. We'll do message : tween position udim2.new 0.50 -0.10 out linear 1 true. And this true is important with tweening because it makes sure that the tween can occur. Otherwise, you will run into some issues. So as you can see. Okay. And so we'll just make a local message can tween, just so it's not choppy or anything. We'll set it equal to false, or in fact, we'll set it equal to true. And so if message can tween equals true, then oops. And so we'll do message can tween equals false. Then after message can tween equals true, we'll actually set this to 0.1 1, 5, and we'll do the same here. 1, 5. The other thing is you're going to want to set this, it might look a bit weird on desktop. Might be a little, it might be a little low on desktop, and that's because there's that little bar for like the menus and stuff. We'll actually set that to wait true because it's looking like it's waiting 1, and then because the tween finishes after a second, it's tweening back. So it'll look a bit funny on desktop because, you know, it's kind of like a little low because of this spot here with like your menus. But on consoles and other devices, it'll look a bit more normal. So we'll just keep it like that. And then we'll set the text here to can't place an object here. So as you can see, you can't place an object here. Get rid of the print here. And so that's really it for making it to where we could place our object on specific ground. I knew raycasting would be the best option here, and it's not the hardest thing in the world, so yeah, it really worked out nicely. It worked out better than I expected it to, honestly, so it was a good call on me choosing the user raycasting. So yeah, that's making sure that you can place your object on specific ground. Our next episode is most likely going to cover at least making it to where you can place multiple objects. So we'll have to do a lot of renaming here because I've used clone chair for the variable title. We're going to have to do a lot of renaming in the next episode, unfortunately. But yeah, this is episode 3 in our placement system, where you can now place your object on specific ground. So yeah, if you thought this video was helpful, don't forget to like the video and subscribe, as well as ring the bell on my channel. I try to upload at least once a week, the best I can. This video was a bit late, so I'm sorry about that, but usually on Fridays in the afternoon I'll try to make and post a video. The next placement system video should be this Friday, because I guess I just want to finish up the series and then move on to some other stuff, like maybe get the tutorials done. I just want to finish this series up, you know. Also have another video planned, but yeah, that's it for this video. See you.